everyone. So in this video we are going to continue from task 1 of this project, see malloc and free. So this question here says we should write a function that returns a pointer to a newly allocated space in memory which contains a copy of the string given as parameter. So when you look at this here, this is a function prototype and it takes in just one parameter, which is a string. So what this question is asking us to do is to write a function that will create another space, okay, another extra space, and in that space it should store the copy of this parameter passed to the function. That's just what we want. Okay, that's what the question is asking us to do. So the function returns a pointer to a new string which is a duplicate of string str. Okay, so what we're going to return is going to hold the exact duplicate of str. So memory for the new string is obtained with malloc and can be freed with free. Okay, so returns null if str is equals to null. On success, the function returns a pointer to the duplicated string. It returns null if insufficient memory was available. So this is just saying that if malloc fails to allocate memory, it should return null. And I've already told you the reason why malloc might return a null, because the memory is exhausted from the heap, right? So how do we do this now? First, let's open the file. There's a file 1strdup.c, right? So I will say vi pastes. All right, so as you can see, I have my Betty documented, right, to avoid time wastage. So what's the first thing we need to do? We said that for us to use malloc, we need to declare a pointer which is going to store or hold the return value of malloc, right? So I will say char asterisk, so let me call it copy. Why am I declaring it as a char? Because the string in which we are going to store because the string in which we want malloc to allocate memory for us to store inside is what is a character, right? So I will do this. So what's the next thing we need to do? The next thing we need to do is this. For us to be able to use malloc, we need to know the exact number of characters that this str is holding, right? We need to know the exact characters. So it means we need to create a function that will find the length of the string, isn't it? So let me declare another variable which I'm going to use for holding the number of characters in str. So let me call it count, and I will initialize it to 0. So this count here is going to hold the number of characters that str have, right? So with this, I'll be able to know the exact amount of memory I want malloc to allocate to me, right? So now let's find the length of the string. So I'll say for I equals to 0. I'm sure this is not something new. So str index I, as far as it is not equals to the terminating null byte. This is not something new. I'm sure we've been doing this when we're talking about pointers. So I plus plus. So here I will just say count plus plus. So I'm now incrementing the value of count for each iteration of I, right? So now count is going to hold the exact number of characters that str have, right? So the next thing we need to do is what? We need to pass this condition here. They said if str, where is it? I can remember it's stated somewhere. If str is equals to null, we should return null, right? So I'll just say if str, or what I need to do here is this. Before I need to do that, I need to pass a condition before the for loop, right? It needs to check if str is equals to null before this for loop should go on, because if str is equals to null, it will not know until after the for loop runs, and that's not what we want. So we want str to be checked first before the loop. So I just say if str is equals to what? Is equals to null, right? So if it is equals to null, our function should return a null, isn't it? So we are done with this, right? So here I can now allocate my memory, right? I can now allocate memory. So what I need to do is I'll just pass in copy, and then I will say malloc. This copy is the pointer we created to hold the return value of malloc, right? So I'll just say size of what? I'm passing what? A character. I want to store a character in the memory allocated to me by malloc. So I just say size of char, and then times what? How many characters am I storing in the memory? Count is holding the number of characters, isn't it? So I'll just say count here. So but there is one thing we need to know. Count here is not going to count including the terminating null byte. So it means that if I leave it like this, malloc is just going to allocate memory for me without giving me an extra space to add my terminating null byte. And if I don't have my terminating null byte at the end of the string, then it means that what? That's not the end of the string. And I need to what? I need to use it at the end of the string to signify that that is the last character of my string, or that's the end of my string. So all I'm going to do is I'll just say plus 1 byte. So it's going to add an extra byte to count, and then it will multiply to its size of char. So this way I'm going to have the exact amount of memory I need, including a space for the terminating null byte. Do you get it? I believe this is clear. So now the next thing is we need to check. I kept on saying this, that after you allocate memory to a program, you need to check if the memory is allocated or not, and they've stated it clear that we should do that here as well, right? So I'll just say if copy is equals to none, so it means what? Malloc fails to allocate, right? So I'll just say return null. So I'm done with this condition, right? So what's the next thing? I'll just say else, right? So that is if malloc is equals to what? Sorry, if the memory is being allocated to us. So what should we do here? If you like, you can remove the else statement. Let me just remove it. It's not necessary. So I can just begin copying the string. Since in this location I'm asked to store what? A copy of str. So I will need a loop to iterate over str entirely, and for each iteration of str I'm going to copy whatever is at that iteration into what? This copy here, okay, this newly allocated space. So all I'm going to do here is I'll just say for I equals to 0, right? So I'm going to iterate over str entirely, right? So I need to pass in stri, right, not equals to the terminating null byte, and then I plus plus. So this is going to loop over the entire str, right? So and for each iteration of str, I want to copy it to copy here, this newly allocated space for me. For each character of str, take it to copy and store a copy of it. So I'll just say copy index I is equals to what? Str index I, right? So it means that whatever is in index I of str, copy it to index I of copy. So whatever is in str index 0 will be copied to copy index 0. Whatever is in whatever when I increment 1, whatever is in str index 1, it will be copied to copy index 1. Str index 2 will be copied to copy index 2. That's how it will keep going. Okay, so what do we need to do at the end? It says we are going to return what? A pointer to the newly allocated space, which is what? Which is copy, right? So I just say return, and then I will pass in copy. That is the pointer to the newly allocated space, right? So let's run Betty on this. So Betty, okay, parenthesis required around a return statement. Okay, I missed a parenthesis somewhere. Which return statement is that? Okay, here, this part here, the L is supposed to be within the bracket. I think that's all right. So let's run Betty again. All right, so Betty is happy. So let's create the test file and let's test our function. Copy. So as you can see here, we also have what? The free function here. So that's why I've not added the free function in my code. Okay, so here I'm going to say vi one main.c. All right, so paste. All right, so here add hash I. All right, so let's compile the program and let's see the output. So copy, paste. Whoa, so undeclared. Okay, did I not declare the variable I? Yeah, I've not declared the variable I. Sorry for that. So I'll just say int I here. I think this is okay now. So let's compile again. Yes, it has been compiled. So let's run the compiled file. So did you see that we got ALX SE, right? ALX SE. So if you can go through the file here, you'll understand why we got this ALX SE here. When you look at this S here is holding what? The return value. This is where the function is being called, and this is the parameter pass function, ALX SE. So it means that the function is going to print what? Exactly ALX SE, because we've designed the function in such a way that it will create a copy of whatever is passed to it as parameter. That's why we're having ALX SE printed. Do you get it? And as you can see here, it is checked. If S is equals to null, it will print this. That is, if whatever this function is returning is null, it's going to print null and return 1 here. And the function is freed at this point. Okay, so that's all how to do this thing. Okay, there are different ways to solve this problem, or to solve any problem. Like I said, this is just one of the ways. You might have your own ways of solving the problem. So we are going to stop here. Don't forget to add commit and push to your GitHub, and then run your checks. In the next video, we are going to continue from task 2 of this project. So thank you very much. Till we meet in our next session.